All right, folks, welcome to the review for the matrices. We'll try it this way with the video. You can fast forward it, just get to the things you need to see. Make it a little more user, controller friendly, you being the user. All right, go through a couple of these, not all the problems. Perform the indicated operation if possible. If not possible, state the reason. Well, again, for matrices, you can't perform it if the size of the matrices don't line up. So you don't have to explain that. But anyway, this is a scalar, so you got to multiply by 2 for every element. So your answer will be 2 times each element. 4, 8, 6, 2, 6, and negative 10. Over here you're adding them, and you got to make sure they're the same size. So they're 2 by 2 and 2 by 2. So yes, you can add them. And then you add element to element. Okay, just add it up like that. Okay. Here goes. 2 and 3 is 5. Negative 1 and negative 4 is negative 5. 1 and 1 is 2. 3 and 2 is 5. There's your answer for number 2. Down here, now the matrices have names A, B, C, and then you have to perform the operations listed below, if you can. So number 3, take B and A and add them together, so you can be adding these two together. So it's 5 plus a negative 3, so that's going to be a 2. Negative 7 and 11 is going to be a 4. Negative 3, negative 4 added together is negative 7. 9 and 2 is 11. For number 4, you're adding C with A, and if you look at those two matrices, they're different sizes. You cannot add those, so just can't do it. Down here we have the, an equation, okay, and you have some variables in here with X and Y. So you just, at the end of this, you're going to have equations solving for X and Y, if you recall when we did these. So, and you're going to have, you may have as many as 4, because a 2 by 2 matrix has 4 elements. In the end, you may actually have 4 things to solve, but generally, you just got to find the X and the Y once each. So I'm going to go through all the operations. I'm going to do the scalars first, those two matrices. So I have 2x, 4, negative 10, and 2y. Everything's multiplied by 2. Plus, the second matrix, everything's multiplied by 3. So it's 6, negative 3, 12, and 3. And this still stays the same. Nothing's happened out here. And 7. Okay. Next step, now I'm going to combine the two matrices on the left, set them equal to the matrix on the right. So again, just so you're clear, it's the 2x plus the 6 equals the 12. And you do that for all 4 element groups. So here goes. So it's 2x plus 6. That's the first element, upper left. 4 plus 3 is a 1. Negative 10 plus 12 is 2. And 2y plus 3. 2y plus 3. It still equals what we had on the right. That hasn't changed at all. Now right here you can kind of look and see, well, look, the 1 and the 1 are good. That's kind of done already, right? The 2 and the 2 are done. So that's nice. So all we got to do now is, 2y plus 3 equals 7. All right, and the 2x plus 6 equals 12. That's the only thing we got to do yet. So here we go with my two equations. 2x plus 6 equals 12. And the other one was 2y plus 3 equals 7. All right, so I'll just go and solve for x and y here. So subtract 6, 2x equals 6. You divide by 2, x is 3. And over here we subtract 3, so 2y equals what, 4, so y equals 2. Next page, now we're multiplying. Remember when you multiply, it's a really good idea to write down the sizes of the matrices. So this is a 1 by 3, right? Again, you have 1 row and 3 columns, okay? And then this one's a 3 row by 1 column. So this is a 3 by 1. All right, so now we can multiply them. And when we're done, the answer will be a 1 by 1. So it's not a very big answer, so we just write our little matrix down here. And remember, everything is RC, so we're going to be going RC, row, column. And there is only 1 row here and 1 column here. So that's why the answer is 1 by 1. All right, here we go. So 2 times 1, oops, let me get rid of this circle. 2 times 1 is 2, plus 1 times 3 is 3, and negative 1 times 2, or negative 2 is 2. So I add that up, I get 4, 7 is the answer. And again, it's a 1 by 1 matrix. All right. Next one. Again, checking the sizes. It's 3 by 2. 3 by 2. This is a 2 by 3. 2 by 3. So my answer should be a 3 by 3, those numbers. So I make a pretty large matrix. And when you make these matrices, make sure you make them really big. And I like to, kind of show where their locations are, rows and columns. So now I know, like for instance, this one here is row 2, column 3, R2, column 3. So that's going to be row 2 in column 3. They fit. They go into places where they come from. Second row, third column goes to the second row, third column. All right, let me get rid of that mess. All right, one more thing, get rid of this. All right, so here we go. Again, this is row 1, 2, and 3. That's rows, and this is column 1, 2, and 3. So I'm going to start with row 1, column 1, which goes here. I'll be marking all these up. 2 times 2 is 4. Negative 3 times 5 is negative 15. Okay, now I'll go to row 1, column 2, and that's right there. So it's 2 times 1 is 2. Negative 3 times 3 is negative 9. And then over here, we're going to go now to, this is row 1, column 3. Row 1, column 3. So we have 2 times negative 1 is negative 2, negative 6. And we'll clean those up later. All right, now I'm going on to row 2, column 1. Well, this is row 2, column 1 right there. So 4 times 2 is 8. Negative 2 times 5 is negative 10. And just to continue on, I'm still in the second row, second column. 4, 1 is 4, negative 6, negative 4, negative 4. Now I'm into the last row and first column. So 0, that's great, negative 1, negative 5. Just negative 5, because the 0 cancels that out. And then negative 3 over here, because again the 0 cancels out. And the last one is negative 2, because again the 0 cancels out. But now you got to just simplify that the rest of the way. So coming down here, and it's going to use a little smaller matrix now. So this is going to be negative 11, negative 7, negative 8, negative 2, negative 2, negative 8, negative 5, negative 3, negative 2. And there's your final answer. All right, now they want you to find the determinant. Just find the determinant. Again, just stuff we just did. So again, you're going to have to first write those first 2 columns down again. So negative 2, 2, 0, 1, 4, 0. And then, of course, we're going to do our little diagonals. There's 1, 2, 3. And let's get the colors here for you to keep things consistent. So I'm going to multiply those out. Negative 2 times 4 is negative 8. This is going to be a positive 16. So it's 16 plus. There's a 0 there, so it's a 0. And the last one also has a 0. Beautiful. Love that. Now I'm going to forget you subtract. And now I'm going to change colors here and go to the other directions. This diagonal, and then this diagonal. So here's those colors. And the first one's 0. Next one is 0. The last one is negative 4. So I have 16. I should change the colors for that. That's going to be blue, yeah. That's a 16 minus negative 4. Well, you have to add that because it's double negative. The answer is 20. All right, now the area of a triangle. Again, take the 3 points, put them into a matrix, and put the placeholders ones of a 1 with all of them. Okay, so here goes. Don't forget, you got to take half, plus or minus half of the value. So we have, I'll just keep the colors consistent for you. Negative 4, 6, 1, 0, 3, 1, 6, 6, 1. Okay, and then I repeat the first 2 columns. So it's negative 4, 0, 6, 6, 3, 6. And don't forget, it's plus or minus 1/2. So there's your setup. And now, again, we're doing our diagonals. There's the first, there's the Sometimes you can get them off here a little bit. Yeah, it goes like this, and then like that. So that's why I say the spacing kind of helps you see where things go. My spacing wasn't so good there. Got a little lost. All right, so we're going to negative 4 times 3 is negative 12. Again, this is, don't forget the plus and minus, 1/2. This is negative 12, 36. And then there's a 0 for the third one. I'm not going to write that. And then going now on the upward diagonals, 1, 2, and 3. And now we have 18, we have negative 24, and we have 0. So there we have it. We can just combine things and finish this up. So back to the blue here. So plus and minus 1/2, this becomes 24 minus, and on this side we have negative 6. You combine that together, negative 6 and 24 gets you 30. So now I have as positive 30. So it's going to be 1/2 of 30, which is equal, and again, it's already positive, so I don't need that. So it's going to be equal to 15. That's the answer. We're not going to do those. Find the equation that goes through these 2 points. Now again, this is where you build your matrix with the x and a y. So you have x, y, 1. You have 1, 8, 1, and 7, 4, 1. And then it's set equal to 0, but I like to write my first 2 columns again. X, y, 1, 8, 7, and 4. Now that all equals 0. All right, so here we go, doing our diagonals. 1, 2, 3. And we have, 8x, 7y, and 4. And now we'll change to the other diagonals, going up, up, and up. And now we have 56, x, 4x, yeah, 4x. And last one is y. That equals 0. And now again, before I do anything else, everything's on one side now. I just got to combine like terms. But this subtraction has to carry into all the other terms to the right, so we got to change all the terms. So this becomes a positive, negative, negative, negative. Okay? And now when I combine all that, x's are first. So I have 8x minus 4x, so I have 4x. I have 7y, and I subtract the y, so it's 6y. And 56, negative 56 and 4 is negative 52. And now I just got to get y by itself, and then I'm done. So subtract the 4x and add 52 to both sides. So I'll show that to you real quick. I don't think I have any amount of room here, so it's going to be a little funny looking here. Plus 52. Over here, I subtract 4x and add 52. I know I'm out of room, so I'm going to be here 6y equals negative 4x plus 52. Divide by 6, and you're kind of done here, right? You have y equals negative 2/3 x. I know this doesn't go in evenly over here, but 8 and 2/3. Yeah, 8 and 2/3 plus 8 and 2/3. And there's your answer for that.